The Playfair cipher is a cryptographic method and it is an example of how encryption evolved to protect the messages from an unauthorized access. It includes a polygraphic substitution, meaning that it encrypts the letters in the pairs rather than individually. This approach increases the encryption complexity and makes it harder to decipher using simple frequency analysis. By focusing on two-letter units, it achieves a higher level of security compared to monoalphabetic ciphers. Building a key. To encrypt a message, we first need a key represented as a 5 by 5 square grid. We will see this in the example. This grid is filled with the alphabet, but its order depends on the keyword chosen by the user. Repeated letters in the key are omitted and the remaining alphabet completes the grid. The letter Z and letter I are often combined. Encrypting the messages. Firstly, the message is prepared by breaking into the pair of letters. If the message contains an odd number of letters, a filler letter like X is added. Then specific rules based on the position of the letters in the grid are applied to substitute each pair with the corresponding cipher text. Then the result is encrypted, called as a cipher text. Same is the process for deciphering. To decrypt a Playfair cipher, the process is reversed using the same key grid. Each pair of cipher text is located in the grid and decryption rules are applied to reveal the original message. This systematic approach ensures the accuracy in recovering the hidden information. For example, you can see over here, the keyword is placed in the grid followed by the rest of alphabets. Strength and weaknesses. The Playfair cipher was one of the first widely used ciphers, valued for its historical significance. So the strength includes enhanced security over simple substitution ciphers, making it harder to break. However, it has vulnerabilities. For instance, a large amount of cipher text could make it susceptible to frequency analysis. Despite this weakness, it served as a significant advancement in cryptography. Its modern relevance. It holds a key example in the history of cryptography. It helps teach the basics of encryption methods. It lays the foundation for understanding more advanced ciphers and cryptographic algorithms. Let us see now one example based on this. In order to encrypt the plain text using Playfair cipher, we will follow some encryption rules. The first one is digraph. We will be drawing a digraph, that is converting the plain text into a pair of two. Second one, repeating letters or filler letters. Again, if there occurs any of the repeating letters in the plain text, we will replace it with some another letter. Also, if there are odd number of letters, replace the remaining letter with some kind of X or any another letter. If this letter occurs in the same column, you are supposed to wrap it around. Also, if they occur in the same row, again wrap it around. And if this pair of letter occurs in a rectangle form, just swap it. Now we will see example based on this. Right now, a key given to us is monarchy. So firstly, we'll be following all the encryption rules. Draw a grid of 5 by 5 and enter the key one by one. Whichever are the remaining letters, fill all those letters and usually combine the letter I and Z. Since we have 26 letters, one letter will be remaining. So combine letter I and Z. So this is how we have drawn this agreed of 5 by 5. Now our plain text is attack. The very first rule is we will be drawing a digraph, that is we will be converting this plain text into a pair of two, AT, TA and CK. In this letter there is no any repeating letter or no letter is left blank. So we can just convert it into ciphertext directly. Now the search for first two letters of plain text, that is A and T. A occurs over here and T occurs over here. If you could see, this forms a rectangle, A and T. So if it forms a rectangle, what are you supposed to do? You are supposed to just swap the letter in the row itself. So for A, you have the letter R. For T, you have the letter S. So the ciphertext will be A. For A, you have R. For T, you have S. R, S. In the same way, find it for T and A. Again, if you can find T and A, this forms a rectangle. So just swap the letters. For T, you have S. For A, you have R. Next is C and K. C occurs over here and K occurs over here. Again, they are not in the same row or they are not in the same column. They form a rectangle, this kind of rectangle. So just swap the letters. For C, you will be having D. For K, you will be having E. This was the first example we have seen. We'll go for the next example, that is Mosque. Again, form a digraph. Convert plain text into pair of two, MOSQUE. Firstly, find out for the MO. MO, see M and O, they occur in the same row. So just you are supposed to take the next letter over here. For M, the next letter is O. For O, the next letter is N. So see, ciphertext is O and N. Next is S and Q. S occurs over here, Q occurs over here. Again, the letters occur in the same row. For X, the next letter is T. And for Q, the next letter is S. So we have written the ciphertext as T and S. Then U and E. U is over here and E is over here. So if you could find, this letter occurs in the same column. If they occur in the same column, again you are supposed to take the next letter. If next letter is not present, you are supposed to wrap around. So after U, there is no next letter. So just wrap around and take the next letter as M. So for ciphertext for U will be M. Ciphertext for E will be L. This is how we will be calculating the ciphertext. Next, if you could see one more example, that is balloon. Now again divide it into a pair of two, BALLOON. Now if you could see over here, see double L. That is, there are repeating letters. If there is any of the repeating letter, replace the second repeating letter with either X or any another letter. So see, BALX. Now this L will be shifted to the next position. So L, then this O comes over here and this N comes over here. Accordingly, we will be calculating the ciphertext over here and we get the answer as IB, SU, PM and NA. If in this case there was no repeating letter and this, if N was single letter, replace the next letter with something X or any another filler letter. In this way, complete it, make a pair of two and using a grid of 5 by 5, find out the ciphertext.